to day 1 of 3 of the webinar series on reducing roadway departure crashes. My name is Mike Fitch with the Ohio LTAP Center here at ODOT, and we appreciate your participation. As we get started, please take a moment to locate the questions box in the GoToWebinar panel. During the presentation today, please use the questions box to send in any questions you might have. Also, looking at the handout section of the GoToWebinar panel, please note that a copy of today's presentation is available for reference. With that, we will turn things over to Ron Eck. Good morning, Ron.
Morning, Mike. Thank you. Welcome, everyone. Pleased to see such a good turnout today. As Mike said, I'm Ron Eck with the West Virginia LTAP. I'm joining you today from Morgantown, West Virginia, which is where I live. And we're here to talk about reducing roadway departure crashes. Quickly about me, I'm a civil engineer. My background is focused on traffic engineering, road safety, those sorts of issues. And you see my email address there. Feel free after the session to reach out if you have questions or concerns. I'm always glad to try to help. So let's get started. Here's the outcomes that I hope you will gain by the time we wrap up on Thursday. I hope you'll be able to describe the roadway departure crash problem. I hope you'll be able to describe the systemic safety approach and compare it with other methods for deploying countermeasures. And I hope you'll be able to describe countermeasures to reduce potential for vehicles leaving the roadway, to reduce the potential for a crash if a vehicle does leave the roadway, and to minimize the severity if a crash does occur. And we'll probably spend most of our time on that last bullet, those three sub-bullets. I've broken this down into what I call 6 parts over 3 days. Today we'll do a little bit of an introduction and overview about roadway departures and about implementation approaches in part 2. Then we'll talk about keeping vehicles on the roadway using signing and delineation techniques. And that will probably bring us into day 2 tomorrow as well. In part 4, we'll talk about keeping vehicles on the road using pavement and geometric techniques. And then we'll talk about improving the recovery area, which will probably bring us to the 3rd day, as well as minimizing the severity of crashes in part 6. So that's our agenda over the next 3 days. Why don't we get started? Part 1 is the introduction and overview of the roadway departure crash problem. And here are the specific learning outcomes for this portion, this part. I hope you'll be able to describe the roadway departure crash problem, define what we mean by roadway departure crash, and understand some of the risk factors for addressing roadway departure crashes. Before we start, I did want to talk a little bit about some terminology and some concepts, starting with crashes versus accidents. When I first started practicing traffic engineering, probably 40 some years ago, we used to refer to those incidents as accidents. And somewhere along the line, I can't remember where in my career, but maybe 20, 30 years ago, people with a public health background also started investigating motor vehicle crashes because so many folks were being killed and seriously injured on our roadways. And those people had a background, as I said, in public health, epidemiology, and similar sorts of fields. And they raised the issue, why do you call them accidents? Accidents sort of implies that these things just happen, there's nothing we can do about it, but actually there are things we can do about these incidents. And so about that time, folks started to call these traffic incidents crashes, maybe rather than accidents. So we'll try to use the term crashes this week. And within crashes, several things I'd like to look at are the probability of crashes, the severity, and what's called exposure. So let's look at each of those. So probability of a crash. We're all concerned about crashes. That's probably why many of you are here and want to talk about how we can reduce crashes and reduce fatalities and serious injuries. But the truth is, crashes are relatively rare events. We could sit by the side of a road, probably anywhere, and sit for a day and probably not see a roadway departure crash. But there are certain conditions we know that kind of increase the likelihood or probability of a crash. And here's sort of a humorous example. It's not really related to safety, but I think you can see, notice we have a roadway or a driveway to some industrial or medical facility, and there's a gate, but notice that's about it. Apparently there's no sort of barriers or fencing along the road. And so you can see through the tracks in the snow here and in the grass that there's a high probability of vehicles departing from the roadway to get around the gate. And roadway departure crashes, of course, there's nothing really humorous about them, but if you think about it, there are certain conditions that increase the likelihood or probability of a roadway departure event. I guess one that maybe many of us can relate to, I was here in West Virginia this weekend, but Ohio is just to my west, and probably Saturday into Sunday, we had snow and ice covered roads, and there were a number of roadway departures because vehicles leave the roadway when the pavement is slippery. So that's one sort of condition, an environmental condition, that can increase the probability of a roadway departure when the road surface is slippery. If you think about roadway characteristics, curves, vehicles are more likely to leave the roadway in a curve than on a straight section of road. So curved roadways likely to have more roadway departures. Here in West Virginia, and I think the same would be true in those of you from southeastern Ohio, given our topography, if we have a long and steep downgrade on a roadway, and at the bottom of that grade maybe is a sharp, relatively sharp horizontal curve, that's another location we know from experience that there will be a high likelihood of roadway departure crashes at the bottom of a downgrade with a curve to the right or left at the bottom. So that's what we mean talking about the likelihood or probability of roadway departures. But we're also interested in, and we'll talk throughout the class today, about how to reduce the severity of crashes, how severe the crash is in terms of, is it a property damage crash or injury crash or fatal crash? And we know things about the roadside and the traffic barriers and things that we use where we can reduce the severity of the crash. But in some cases, it may be just a matter of inches or degrees or even luck, if you will, that may determine the severity of the crash. As you see here, notice here we have a roadway departure. The vehicle ended up, it looks like, on its tires right side up with some property damage, maybe some injury to the occupants. But notice, had this happened a few feet one direction or the other, this could very well have been a tragedy in terms of a fatal crash. So there's a number of factors that affect severity, and we'll look at some of those as we go through the next 3 days. And then you may hear the term, or you may have heard the term, exposure. Exposure relates to the amount of traffic on a roadway. For example, if we look at the photograph on the right, that looks like a significant roadside safety issue. Notice the slope is steep. A vehicle won't be able to stop on that slope. In fact, a vehicle probably would overturn on that slope. And then at the bottom, we see a significant water body that poses a drowning hazard. So there's a number of risks there if a vehicle leaves the roadway. And we could say, well, guardrail is needed there. We should have guardrail, and I wouldn't disagree with that. But on the other hand, if I told you this is a very low traffic volume road that has about 20 vehicles per day on it, that may affect your thinking in terms of what sort of devices we might use or barriers we might use, or if we use a barrier, to prevent vehicles from getting on that slope. So that would be a roadway with low traffic, relatively low exposure. On the other hand, the view on the left there, it looks like an arterial type of roadway, more traffic volume, and so there's a higher level of exposure in terms of traffic volume. And we see a significant roadside issue there as well. That brings us to roadway departure crashes, and you see at the bottom the definition of a roadway departure crash. It's a non-intersection crash in which a vehicle crosses an edge line, meaning to the right, a center line, meaning to the left, or otherwise leaves the traveled way. So sometimes you hear, and I also like the terminology, you'll hear these crashes referred to as lane departure crashes, because notice the vehicle crosses the center line into the oncoming lane. It hasn't really departed the roadway, it's departed its lane of travel. And so maybe lane departure might be a better term to use to describe these crashes. So I'll probably use the terms interchangeably, lane departure or roadway departure crash, but regardless, this would be my definition that I'm referring to. You can see it varies, of course, from year to year, but generally it's a little bit above 50% of all roadway fatalities are roadway departure crashes. And you can see those can be run off the road to the right, which is about a quarter of the fatal crashes, run off the road to the left, maybe about a half that, 10%, and then crossovers, meaning leaving the motorist lane of travel going to the left, crossing into the opposing direction of traffic. And then non-roadway departures, usually between probably 45 and 50% of fatal crashes each year. Looking at some fatal crashes in the United States, this is a little bit dated, but you can see the numbers in each state are the number of fatal crashes averaged for those 3 years. And it's kind of like a heat map. The red and yellow colors mean relatively high numbers of crashes. The blue and the light green color mean relatively lower number of crashes. And remember, I talked about exposure. This is a good example of how kind of exposure relates to this, because you'll notice the quote hot flows, especially the reds, are the high population states: New York, Texas, California, Georgia, Pennsylvania. Those high population states, higher traffic volumes, and so we would expect, because of the higher exposure, we'd expect more fatalities. And that is in fact the case. And then you can see other, like Ohio, Tennessee, Missouri, Illinois, other relatively high population states are still in the kind of the warm colors, if you will, and still have relatively high numbers of fatalities. Whereas the upper Midwest and Northwest, lower population states, lower exposure, and so they have fewer fatal crashes. I guess I would notice in the East, my home state, West Virginia, stands out as a cool color surrounded by the warmer colors of the states nearby. But again, that's because West Virginia is more sparsely populated, has lower population density compared to the surrounding states. If we look at the same thing for roadway departure fatalities. So this is fatalities, but these are roadway departure fatalities. Notice that roughly the same thing holds true. The higher population states have the warmer colors. The lower population states have the cooler colors. Now, if we look at the percent of roadway departure fatal crashes, notice how the coloration sort of switches now. Those states that previously, based on exposure, were had high numbers of fatalities, roadway departure fatalities or total fatalities, now they show up in more of the cooler colors, whereas many of the states that showed up in the cooler colors now show up in the very warm colors because they have a higher proportion of their fatals that consist of roadway departure fatalities. And interestingly, I've noticed my home state, West Virginia, notice now on this measure, West Virginia shows up as a warm color. In fact, I think if you look at the number there, I think for these 3 years, West Virginia had the highest percentage of roadway departure fatalities, 75%. So in West Virginia during that time period, 3 out of every 4 roadway departures was a roadway, 3 out of 4 roadway fatalities was a roadway departure. So roadway departure crashes are significant. The figure now is about every 30 minutes, there's a roadway departure fatality, meaning on an average day, about 48 people will die in roadway departure crashes. And to maybe bring it a little closer to home, if you think we're going to be in class here for 6 hours during this week, if this is an average week in the United States, while we're in this class, there'll probably be 12 people nationwide that will die in roadway departure crashes. So it's a significant safety issue, which is part of the reason we're going to spend some time this week talking about it and talking about how we can reduce roadway departure fatalities and serious injury crashes. Bring it a little closer to home. I know we may have folks from other states, but Ohio LTAP is sponsoring this class, so I'm going to focus on Ohio data. And of course, there's always a time lag of a year or two between the end of the year and when the final roadway statistics are published. So this was the most recent full year of data for Ohio. Notice there were about 7,500 serious injuries in Ohio in 2023, and this was actually down from the previous year. About 1,250 fatalities, which was also down. So these trends are favorable. And notice there were about, Ohio calls them lane departure fatalities, which I mentioned earlier. So lane departure fatalities were about 615, which was also down. And so that roadway departure percentage of all fatalities is about 50%, which I think is roughly consistent with what I mentioned nationally. I think nationally it's a little bit higher than 50% in terms of the roadway departure percentage of fatalities. And if you look at some FARS data, the fatal accident reporting system, again, this is for 2023. And again, this is all crashes, total fatalities by county. So again, remember, this relates to exposure. This is kind of like a heat map. And so you'll see your warm colors, the reds and the pinks and the yellows, not surprisingly, are in the higher population areas of the state: Cincinnati, Columbus, Cleveland, Toledo, Dayton. Those areas, higher population, more vehicle miles of travel, and so they'll have more crashes. But interestingly, notice it looks like there's a couple counties there in the northwestern part of Ohio that had no roadway fatalities in 2023. That's a good thing. And if we now break it down a little more and look at Ohio fatalities by county, this is crashes involving a roadway departure. So this is a subset of the previous numbers. Again, it's the heat map, so the higher population areas should have more fatalities, and the more rural areas should show up in the cooler colors. And the same, you can see, is different, but a little bit of the same pattern. The high population areas tend to be the warmer colors, the more rural areas, the blue and light blue. But interestingly, notice there's a handful of additional counties that in 2023 did not have any roadway departure fatalities. So that's a good thing as well. Like other states, Ohio has a strategic highway safety plan. This is the 2025 Vision Zero Ohio Strategic Highway Safety Plan. I'm not going to get into detail in it, but I did want to mention, as you may be aware, states identify emphasis areas that they want to focus on. And you can see here Ohio's plan, the emphasis areas. Roadway departure is there, intersections. You can see this includes not only the roadways, but the vehicles, education, enforcement, data, technology, railroad grade crossings, a variety of things. But what I wanted to point out is that roadway departures are one of the Ohio emphasis areas. And I think that's true in most states where I've reviewed their strategic highway safety plan. Roadway departure is one of the emphasis areas because it is an issue nationally. But I did want to mention just quickly, we're going to focus on the roadway departures since I think most people here are involved in the roadway and public works side of things. But some of the other emphasis areas obviously relate to roadway departures as well. For example, speed. Probably the higher the speed, the more likely someone is maybe to depart the roadway at some point. And it may also be related to young drivers, for example. It's known that younger drivers tend to be more aggressive maybe than the rest of the driving population. So younger drivers may factor into this issue as well. And then the last item there, seat belts or restraints, that also factors into roadway departure fatalities, because if a vehicle leaves the roadway and the car overturns on a slope or may hit a fixed object, if the occupant is not belted, they may be more likely to sustain fatal or serious injuries, or especially in roadway departure crashes, the occupant is not belted. Many times the unbelted occupant is ejected from the vehicle, strikes the ground or strikes the pavement, or may actually be struck by the vehicle when the vehicle comes down or is rolling over. So you can see there's obviously some kind of interaction and overlap here in some of these other emphasis areas that we're not probably going to mention as we go through the next couple days. And also, like other states, Ohio's Strategic Highway Safety Plan identifies some strategies for each of the emphasis areas. And here are the strategies for roadway departure crashes. Notice they want to reduce roadway departure crashes on high-risk roads through systemic treatments. And these could be signing, pavement marking, or other sorts of systemic treatments. They also want to provide assistance and resources to local agencies to mitigate severe roadway departure crashes. Promote and enhance LTAP and local programming resources for roadway departure safety. So as an LTAPer, I'm glad to see that the plan specifically mentions promoting and enhancing LTAP. And it's probably fair to say this offering of this reducing roadway departure crashes is consistent with that strategy. Now, reviewing ODOT policies and standards for roadway departure crashes. And then lastly, explore nuances of different context environments to better inform future priorities and strategies. So this would probably be from experience, but also probably some research to see how we can develop additional information or guidance that should help us as it says here, inform future priorities and strategies. So with that background, let's look a little bit in more detail at some of the characteristics of roadway departure crashes. This first one shows the first harmful event in fatal roadway departures. So this is the first harmful event, the first event that caused harm in a roadway departure crash. And notice you can see the light blue on the right of this pie chart is a fixed object. Excuse me. So you can see almost 60%, in almost 60% of fatal roadway departure crashes, the first harm object, and this could be a utility pole, a tree, a rock outcrop, those sorts of things. Notice about a quarter of the first harmful event was another vehicle striking another vehicle, and this could be a lane departure crossing the center line into the opposing lane and striking another vehicle. In about 1 out of every 6 of the fatal roadway departures, the first harmful event was an overturn, meaning probably the vehicle left the road on a steep slope and the vehicle overturned. And then in 2% of the cases, the first harmful event was pedestrian or bicycle. Changing it up a little bit, this is roadway departure fatal crashes by the most harmful event. The previous slide was the first harmful event. This is the most harmful event. What was the event that caused the most harm to the vehicle occupants? And you'll notice if you look here, breaking it down in percentages, notice there's, I call them the big three, kind of 3 categories of roadway departure fatal crashes that you can see make up almost 3/4 of roadway departure fatalities. And those are the overturn, opposing traffic, for example, a head-on crash if a vehicle crosses the center line, and then trees and shrubs along the roadway. And so if we, like I said, if we kind of remove those, it's about a little less than 3/4 of the roadway departure fatalities are due to these 3 types of crashes. And if we look at each of these in a little bit more detail, looking at our first category here, which was the overturn, and then we'll look at opposing and traffic, and then trees and shrubs. Notice that for the overturn, the risk factors are rural areas, which is where the slopes, side slopes would be along the roadway. Posted speeds greater than 45 miles per hour. So we're talking about rural road speeds, probably as opposed to city street speeds. And then curbs. I think we've talked about already, roadway departures tend to be overrepresented in curves. If we look at opposite direction crashes, some of the risk factors, undivided roadways, which is not surprising, right? It's easy for a vehicle to just cross a painted center line as opposed to a median, for example, or a median barrier. Again, notice one of the risk factors is rural areas and posted speed greater than 45 miles per hour. Again, curves show up as a risk factor, and interestingly, adverse weather. And this could be rain or fog or snow and ice, but under those adverse weather conditions, drivers, maybe vehicles, more likely to cross the center line into the opposite direction of traffic. So fixed object crashes overall were 19, into trees or in shrubs were 19% of the roadway departure, causing the most harm for occupants. But notice trees are 44% of fixed object fatalities. And in fact, as we'll talk about in the United States, trees are the most commonly struck fixed object alongside the road. But you can see some of the other fixed object crashes, signs and poles, barriers. Those are features that we in the public works field, we put those on the roadway to communicate with motorists, to light the roadway, to shield motorists from hazards along the roadway in the case of barriers. So some of these features that we actually put out along the roadway, we need to recognize that they can be and are fixed objects that can cause harm to motorists. So here's a little review. Now, welcome your participation. You can just type your responses in the chat and Mike can share some of those with us. But here's kind of our first review question. Which of these crash types below are included in the definition of a roadway departure crash? Crashing into a fixed object like a tree or pole, hitting a deer in the traveled way, rolling over on the roadside, right angle impacts at intersections, head-on crashes, or hitting a pedestrian in a crosswalk. Which of those do you think would be included in the definition of a roadway departure crash as we've talked about it here? Any thoughts on that?
Yes, thanks, Ron. We have people typing in. Several folks are saying A, C, and E.
A, C, and E. So let's take a look at that. A is crashing into a fixed object like a tree or a pole, which I think by definition will be alongside the road rather than in the road. So yeah, definitely A would meet the definition of a roadway departure crash. C, rolling over on the roadside, implies that the vehicle has left the roadway. So yes, that would be correct as well. And then E, head-on crashes. This would be within the definition as well because the vehicle left its lane of travel and crossed over to the left and struck or was struck by an oncoming vehicle. So good work there. Yeah, A, C, and E. The other items listed there, the vehicle remains within the traveled way, so those would not be considered roadway departures.
Hey, Ron.
Yeah.
Yeah, there's a question. Is there a breakdown of utility poles versus street signs or other objects?
Yeah, there is. A good question. I think I will share that with you a little bit later when we start looking at fixed objects.
Okay.
I think I have a more detailed pie chart. If I don't at that time, then holler at me again and I'll be sure to address that.
Sounds good. Thanks.
Thanks. So addressing risk factors, this is NCHRP Report 500. It's a series of 23 volumes that presents some, identify some roadway safety issues, not just roadway departures, and also some strategies for reducing crashes. It's a little bit dated now, but I think it still has some good information. Some of you may be familiar with it. Later on, I'll provide some links where you can access these online. But they talk about 3 ways to address risk factors, and this has been adopted by others, I believe AASHTO, but also it's the same organizational framework that I'll be using for this class. So they talk about first trying to keep vehicles from leaving the roadway. What can we do to keep vehicles on the roadway? Of course, if vehicle stays on the roadway, we won't have a roadway departure. But if a vehicle does leave the roadway, how can we minimize the likelihood of that vehicle crashing into an object or overturning on the side slope? And then the third method to address the risk factors is to reduce the severity of the crash. So notice in B, we're talking about minimize the likelihood or the probability of a vehicle striking a fixed object or overturning on the slope. But C gets at reducing the severity if a crash does occur. And we'll look at each of these, starting with the keeping vehicles on the roadside first. I'm sorry, keeping vehicles on the roadway so they don't encroach on the roadside. In some of these, I'll be mentioning crash modification factors, or CMFs, and these come from the Highway Safety Manual. They basically account for the difference between the base and the actual geometry or situation. They help us estimate the effects of individual geometry elements or signing or countermeasures on safety. They can be greater than or less than 1. If a CMF is less than 1, that means that the countermeasures such as signing or slope flattening, whatever it might be, reduced crashes. And that's a good thing. We want the CMF hopefully to be less than 1. But let's face it, sometimes we may do something and unfortunately the crash experience increases. So we may have CMFs greater than 1, but that's not a good thing because that means the crash frequency increased after the countermeasure was implemented. You may also see as we go through here, in addition to CMFs, you may see reference to CRFs, or crash reduction factors. This is the percent reduction in crashes that might be expected from a countermeasure. And if we have a negative CRF, that means that the treatment or the countermeasure might be expected to increase crashes. There is a relationship between CRFs and CMFs, and you can see that here. A crash reduction factor is 1 minus the CMF. And so if we have a CMF of 0.9, that's the same as a 10% crash reduction factor. So just kind of keep that in mind as we go through here. For a number of these countermeasures or treatments throughout the week, we'll talk about CMFs or CRFs. So I did want to give a little bit of background. Is a CMF of 1.1 a good thing? And as I just said, no. If the CMF is above 1, that means that that treatment could be expected to increase crashes, which is not a good thing. So hopefully our CMFs will be less than 1. There is a crash modification factors clearinghouse that is an online repository of CMFs, and it's constantly growing, if you will, as research is completed and we develop new CMFs. Those are added to the online repository. So if you're not familiar with the clearinghouse, I urge you to check it out. It also just has some good educational information with respect to countermeasures and crash modification factors. So a review of the learning objectives from part 1. I hope we described the roadway departure crash problem. We defined what a roadway departure crash is, and we talked about some risk factors for addressing roadway departure crashes. Any questions on any of that?
Thanks, Ron. There was a general question from Kessa. She was wondering, will suburban roadway departures, specifically in curbed areas, be covered in this webinar series? She mentioned that in some of her previous trainings, there was more of a focus on the rural scenarios. So I think generally she's wondering if we'll be talking about some of the safety treatments for suburban areas.
Yeah, great question. This will focus probably more like the previous training you had. This will probably focus more on the rural areas. We will talk a little bit about urban, but predominantly it's focused on rural areas.
All right, thanks, Ron.
That brings us to part 2, which I call getting to safety implementation approaches. So looking at how do we determine where and what to do when it comes to roadside safety issues. So our learning outcome here is to describe the systemic safety approach and compare that with other methods for deploying countermeasures. Here we have some implementation strategies. You'll notice at the top there, we'll call this the comprehensive strategy, which incorporates enforcement and education. And then kind of underlying that, we have I call it the engineering approaches, policy, traditional approach, and then the systemic approach. And you can sort of see here the policy approaches generally provide long-term gains. It's standards-based. The traditional approach, sometimes called the hotspot or the high crash location approach, still has value, but one downside of it is it has minimal statewide impact. Whereas the systemic approach focuses on applying low-cost countermeasures throughout the system, and it can have significant statewide or jurisdiction-wide impact. For example, corridor improvements would be an example of a comprehensive approach, looking at routes with high numbers of severe roadway departure crashes, coordinated effort of the traditional 3 E's of traffic safety, the engineering, the education, and the enforcement. Policy strategies. I mentioned that generally you find long-term gains. A good example might be the safety edge. Agencies can adopt a policy to incorporate the safety edge in all their paving projects. That would be an example of a policy strategy to reduce roadway departure crashes. And the traditional approach, I mentioned, sometimes called the high crash location or hotspot approach. You look at those locations that have a high number of crashes. It could be intersections or curves, for example, and then you apply treatments to those specific locations. So overall, there's really relatively few improvements. And as I believe I mentioned earlier, it really doesn't affect the big picture a whole lot in terms of reducing statewide or jurisdiction-wide fatalities. So that's led to looking at other approaches that can overcome some of these drawbacks of the traditional approach. Because as it says here, if you always do what you've always done, you'll always get what you've always gotten. So what can we do to maybe have a greater jurisdiction-wide impact when it comes to, for example, roadway departures? Which leads to a little example exercise here. And this may be where the systemic approach actually started, I think, historically, was in Humboldt County, California, which is a rural county in Northern California. The county engineer was concerned about fatal crashes that were happening in the county. And so his first thought was to kind of do the traditional hotspot approach. So my next slide will be a map of the county showing fatal crashes. And the question is, do you see a place that needs to be treated? So notice each pin, each red pin indicates a fatal crash. But interestingly, looking at it, notice how the fatal crashes are kind of distributed along the county roads. I really don't see a location where there's kind of a concentration of fatal crashes. So this concerned the county engineer because he knew he had an issue with fatalities, but he wanted a way to address them. And so he looked further at the crash data. And I realize these are maybe hard to read, but the actual numbers are not that much, not so important, I guess we'd say. But if you look at these 4 years of data, notice a few things stand out. Notice, for example, in each of the 4 years, the hit object, or we'll say hit fixed object crashes, which is item E on that list, or factor E on that list, they're around 27 to 29% of total fatalities. So that's a roadway departure crash. I think we'd all agree that hit fixed object. But then notice also head-on crashes, about 10 to 12% each year. Also, overturned crashes, item F of the factors there, is about 10 to 12% each year. So it struck him that in terms of fatal crash types, the overturn, the head-on, and the hit fixed object stood out as key crash types. And all of these are, if you think about it, are really roadway departure crashes. So what we can say is that fatal crash locations are random, but fatal crash types are predictable. And so that's sort of the basis for the systemic approach, which we'll look at. So why do drivers leave the roadway? Well, it could be a variety of reasons. We've talked about how it could be roadway condition, icy pavement, or heavy rain, wet pavement. Could be some sort of a polished roadway condition, some rutted pavement that may contribute to leaving the roadway. It could be collision avoidance, not only avoiding another vehicle or a pedestrian, but it could be avoiding animals. That's here where I am in West Virginia, that's a major cause of roadway departures, is drivers trying to avoid a deer or a bear or other animal in the roadway. Could be vehicle component failure, a tire blowout, a steering failure, brake failure, something like that. And it could be driver error, which could include a number of things: fatigue, distraction, falling asleep. All of those things I would put under driver error. So there's a variety of reasons drivers leave the roadway. And here's some data that I think is interesting. The one thing I want to emphasize is, notice there in the lower right, this was produced based on some research conducted by Gary Alexander and Hal Lunenfeld, who were engineering psychologists with the Federal Highway Administration at the time. And so this is around 1980, so it's 45 years old. So this is before the internet was publicly available, before cell phones and handheld devices. So this is kind of a different age, but notice some of the things that they found. Those drivers make 1 to 3 decisions per second. That sounds like a lot, and it is, but they defined maybe even deciding to change the steering angle slightly, or the throttle or the accelerator slightly. Those would be called decisions. But probably for most drivers, experienced drivers, those things kind of just come naturally. It's not like you have to think about all those things, every second. But 30 to 120 actions per minute. But kind of the scary part is notice drivers commit at least one error every 2 minutes and are involved in a hazardous situation every 2 hours. So it would be interesting, I think, now to maybe use some of the naturalistic driving data that's becoming available in the last few years, and maybe kind of repeat this driver error study that Alexander and Lunenfeld conducted. I also wanted to mention, before we get too far into this, the new direction. Some of you are probably familiar with it already, but it's called the Safe System Approach, whose goal is to eliminate fatal and serious injuries for all road users by, number one, accommodating human mistakes, and number two, keeping impacts on the human body at tolerable levels. So this is kind of the wheel that explains or describes the safe system approach. You see the 6 safe system principles around the circumference of this circle. Death and serious injury is unacceptable. Humans make mistakes. Humans are vulnerable. Responsibility is shared, whereas in the past, maybe it was the driver was always responsible, but now it's recognized that throughout the system, we have a shared responsibility. Safety is proactive rather than reactive, and redundancy is crucial. Those are the 6 safe system principles. And then within that, between the spokes of the wheel, if you will, you see the 5 safe system elements: safe road users, safe vehicles, safe speeds, safe roads, and post-crash care. So again, this is not just the roadway or the engineering side of things, but it even gets into the post-crash care and emergency response, like you see here. So safe roads are designed and operated to prevent crashes, and as I mentioned earlier, keep impacts on the human body at tolerable levels. Which brings us to the systemic safety improvement strategy that I alluded to earlier. It's defined as an improvement that's widely implemented based on high-risk roadway features that are correlated with particular severe crash types. And the focus is on lower cost countermeasures. And you can see that it's kind of based on the potential for a specific type of severe crash to occur at a specific location because of that location's characteristic or features. So whereas the traditional approach focus, say, on one curve or one intersection, the systemic approach might look at all curves with certain characteristics on the system or in the network, and then apply low-cost countermeasures at all of those locations. It's kind of the reverse of the traditional approach. Starts with countermeasures, low-cost countermeasures, and then find sections with those targeted crash types and install the countermeasure systematically at a number of locations, curves, or intersections. So it's not limited to the highest crash locations. And using this approach, we can achieve significant jurisdiction-wide reduction of roadway departure fatalities. I also wanted to mention, I'd like to recommend, I mentioned with the safe system approach, we should be proactive rather than reactive. Here's one way of thinking to accomplish that is keep an eye out while you're riding the roadways or while your crews are riding the roadways, and be on the lookout for certain things, certain features, if you will. I call this reading the road, looking for indications that road users may be having problems traveling a section of roadway. Sometimes we can identify issues and take steps to resolve them before crashes start occurring. And here's one example. This is a 2-lane rural roadway in West Virginia. But notice all the rubber tire marks on the roadway. These are locked wheel tire marks. And I think you can probably figure out what's going on here. Drivers heading into the picture come upon this sharp crest curve. In fact, they may be headed over that curve, and that might be traffic stopped in front of them. And so drivers make panic brake applications. And it's not just, you can see one driver, multiple vehicles have left locked wheel tire marks on the roadway. And of course, the issue here is limited sight distance over that curve. But that's an example of reading the road. We might look at a few other examples. Debris from multiple crashes along the roadway. And again, I'm not talking about just one crash, but if you start to see different pieces of crash debris along the roadway indicating maybe there's been multiple crashes. Again, that's an indication probably something's going on at that location. I mentioned locked wheel tire marks. Here's a curve with a number of locked wheel tire marks entering the curve. In fact, notice a number of them seem to head off the roadway, suggesting that roadway departures are occurring. Not sure exactly what's going on here. It looks like the curve is pretty well delineated with chevrons. So I think I'd want to go out there and take a look at probably this whole section of roadway to see what's going on there. But that kind of that clustering of those locked wheel tire marks there at that location does concern me. So that one type of tire mark is the locked wheel tire mark. And if you allow me to back up here, one characteristic of the locked wheel tire marks is that, and accident reconstructionists or accident investigators talk about tire marks. They talk about what they call striations. You get my pointer here. They talk about striations in a mark. So here's a locked wheel tire mark. And if you look closely, you can see that there's lines or striations within that line. And those are called striations. And in a locked wheel tire mark, they will always be lined up with the mark. So the striations will be parallel to the mark. So that's locked wheel tire marks, which is a common type of tire mark. Well, now my screen is frozen and I can't.
The slide's not advancing for you?
No, and I can't get rid of my cursor here. Oh.
Ron, there was a comment suggesting wider lines with better retroreflectivity.
Yes, that for keeping vehicles on the road, I guess that was referring to.
I guess looking at some of these recent photos.
Okay, maybe this one here.
Mm-hmm.
Yeah, but renewing that edge line and probably the center line, yeah, I agree, could probably go a long way in helping keep drivers on the roadway. So I mentioned locked wheel tire marks. Another common type of mark, maybe not as common as the locked wheel tire mark, is the yaw mark. A yaw mark is often called an overcorrection or oversteering mark, and it's made by a tire that is rotating but also sliding along the pavement. And you can see an example on the left there of a yaw mark kind of from a distance, and then a close-up of a portion of that mark is shown on the right side. And notice I mentioned in a locked wheel tire mark, the striations are parallel to the mark. Notice in a yaw mark, the striations are diagonal to the mark. And I think you can see that pretty well there. So that's how an accident investigator or anybody can distinguish a locked wheel tire mark from a yaw mark. But the yaw marks, as I said, are found usually where drivers are kind of overcorrecting or oversteering. So they have a different causation, different source than the locked wheel tire marks. But where you see a kind of concentration of yaw marks on a road, that can be an indication that something's going on. We don't see that here. Notice we just see one yaw mark. That wouldn't necessarily concern me because we can find these marks anywhere. But where you start to see a clustering or concentration of them, that's when I would look in more detail. Or here we see some marks on the road side. And if you look in the center there, which is a blow up of a portion of one of those two curved marks, would you agree that's not a tire just rolling on the roadway? That's a tire that's sliding, because you can see how it's kind of torn up and disrupted the grass or the turf there on the roadside. So this would also be a yaw mark. Whereas on the right side, notice if you look closely, that also is a vehicle or a tire that's sliding, because we don't see any tread marks. And if you look closely, notice how it's kind of bulldozed earth and grass up in front of it. So that's a vehicle that was in a locked wheel skid situation and pushing some of the sod or the turf ahead of it. But notice here, a large number of different marks in this curve suggests that maybe we need to do something to help vehicles stay on the roadway. And in fact, what they did at this location was put chevrons around the curve with advance warning signs and advisory speeds. Gouges, scrapes, and scratches on the pavement. Of course, again, we'll find these really anywhere, but when you start to see a concentration like this, that's an indication that something's going on. Vehicles look like they're overturning and sliding on the pavement. Same thing here, scratches and scrapes on roadside features. Notice this is the same median island, and notice we can see a number of tire marks, rubber marks, I guess I should say, scratches, scrapes. But the interesting thing is, notice how they're all oriented in the same direction. Different vehicles made the marks, but they're all oriented in the same direction. And here, the issue was that this median used to have flexible reflectors, delineators on the median. You can still see evidence of it there, but those were displaced or destroyed over time, and so the median is poorly delineated and vehicles were crossing the median. So the solution here was to install or replace the delineation. Multiple scars on trees. We can see that this tree has been struck more than once. Multiple hits on utility poles and multiple sign strikes. Notice we can see the stubs have been broken off here on the right image, and this particular agency's policy is to date each time the stop sign was reinstalled. And you can see it's been reinstalled quite a bit over time. In fact, it looks like it's being installed on a more frequent basis as time goes on. I guess my question is, why doesn't somebody in the agency kind of say, hey, wait a minute, we're out here all the time replacing this stop sign. What can we do we need to change the location of the stop sign or redesign the intersection, or what's going on here, rather than just continuously replacing the stop sign? So I call that reading the road as well, looking for indications that motorists are having difficulty negotiating the roadway. And here's an example, local road example. If you look closely there in the center above the Sharrow symbol, you can see that there's some damage to the top of the curb. It's kind of a sawtooth pattern. The road supervisor in this jurisdiction saw that and wondered what was going on. Why was that particular pattern of damage to the curb? Why did it exist in this curve but not elsewhere? And notice, you can see in the upper left there, upper right, I should say, in the upper right, there is an intersecting roadway that intersects just outside the image there. You can see the stop sign, but just the intersection itself is just outside the image on the right. But anyway, the road supervisor saw that pattern and did some more investigation, actually went upstream of this section of roadway. Here's what he saw. Notice there's a little hill crest. There's plenty of signing, warning signs and speed limit signs, guide signs and so forth. And then as he drove the roadway, as he went over the hill crest, this is what he saw. And I think you can see now, notice there's that grass area, curbed grass area that we saw in the original photo. And notice how it appears the roadway goes straight ahead, but actually what we're seeing in the distance is the intersecting roadway. And if you think about this, during the daytime, we can see that, but think about this same scene at night. A driver can probably see the street lights along that roadway in the distance. They can see the headlights and taillights of vehicles on that roadway. But what can't be seen is that the curb and the grass area, because those have no retroreflectivity, so they're not going to be visible at night. And so the road supervisor perceived that situation, and what they ended up doing was putting chevrons around that curve to help motorists see the alignment of the roadway at night. In fact, also what they did in that grass area was put sort of a grassy knoll to make it more difficult for motorists to see that misleading road straight ahead in the distance. So there was a case of someone reading the road, figuring out what the issue was, and then installing countermeasures based on that. But read cautiously. As I say, just one mark really doesn't, or one piece of evidence doesn't indicate an issue, but where you see multiple marks of the same type, that may be an indicator of a problem. I notice here on this gravel road, notice these marks leaving the roadway. Those tires were rolling, not sliding, because we can see the tread pattern in the mark. But notice it looks like several drivers apparently made U-turns. So something's going on there. I don't know if drivers have missed a driveway or a side road or something, but it might be interesting to look at what's going on here. Do we need maybe additional signing or advance notice of something ahead? So another example of reading the roadway. As we go through today and the next two sessions, keep this in mind. This is a recognized roadside design strategy, or really it's a hierarchy, if you will, priority scheme for dealing with roadside obstacles or conditions. Our first priority would be to remove the obstacle. If we can't do that, then redesign the object so motorists that leave the roadway can safely traverse it. If we can't do that, can we relocate the obstacle further from the roadway? Maybe move a sign or culvert end or something like that further from the roadway. If we can't do that, can we reduce the obstacle severity, make our signs breakaway, for example? If we can't do that, shield the obstacle. But notice on this list, notice shield is one of the lower priorities, because shielding using barriers or guardrail or those kinds of things, as I mentioned earlier, are also roadside obstacles that can and do cause injury and fatalities to motorists who strike them. And then if we can't do any of those items, last priority would be to at least delineate the obstacle so that drivers can see it. So keep this in mind as we go through the next couple of days. So here we've talked about the systemic safety approach and different methods for deploying countermeasures. We also talked a little bit about reading the road. Any questions or concerns about any of that?
Thanks, Ron. We don't see any additional questions at this time.
Okay, thank you, Mike. That brings us to part 3, which is using signing and delineation to keep vehicles on the roadway. So that's what we're going to talk about. First item is keeping vehicles on the roadway, and we're going to focus on delineation and signing. So these are kind of low cost, short time frame countermeasures. And just to orient you, we're going to look at a number of different things today and tomorrow in terms of ways to keep vehicles on the roadway. In this part, we're going to look at marking and delineation and signs. What are the crash types addressed by delineation? Well, curve crashes, head-on collisions, so lane departure crashes, roadway departure crash, nighttime crashes, and other run off the road crashes. It'd be great if every roadway looked like this at night. It'd be probably easy for drivers to follow the roadway alignment. If they were traveling long distances on such a roadway, there'd probably be minimal fatigue over the length of their trip. So good delineation helps drivers navigate the roadway more safely and with less effort. Some of what we're going to be referring to here when we're talking about signing and marking obviously relates to the manual and uniform traffic control devices. And as you may be aware, kind of three small but important words within the manual. If it's a shall condition, it's a standard, it's a requirement. If it's a should condition, it's recommended or it's guidance. And if the word may is used, it's an option that's available to the practitioner. So let's start with lane lines, yellow center lines. What does the MUTCD say about center lines? The standard is that urban arterials, or for urban arterials and collectors, center line markings shall be placed on roadways greater than or equal to 20 feet and with an average daily traffic volume greater than or equal to 6,000 vehicles per day, and on paved two-way streets with 3 or more lanes. So these are the conditions where center line markings are required on urban arterials and collectors. ECD also provides some guidance. For urban arterials and collectors, note center line markings should be placed where the roadway is greater than or equal to 20 feet in width and the average daily traffic volume is greater than or equal to 4,000 vehicles per day, and on paved two-way streets with 3 or more lanes. On rural arterials and collectors, the center line markings should be placed where the roadway is greater than or equal to 18 feet in width and the average daily traffic volume is greater than or equal to 3,000 vehicles per day, or where an engineering study indicates a need or engineering judgment situation if the travelway has a width of 16 feet. Now turning to edge lines, the white lines on the right side of the roadway, sometimes called fog lines. The standard in the MUTCD is that edge line markings shall be placed on freeways and expressways and on rural arterials with the traveled way of greater than or equal to 20 feet in width and an average daily traffic volume greater than or equal to 6,000 vehicles per day. That's the standard for edge lines. In terms of guidance or recommendation, edge line markings should be placed on rural arterials and collectors with a traveled way width greater than or equal to 20 feet and an average daily traffic volume greater than or equal to 3,000 vehicles per day, or where an engineering study indicates a need for edge lines. What about the effectiveness of edge and centerline markings? Excuse me. Here you see a table from the Highway Safety Manual that presents the potential crash effects of placing edge line and center line markings. And the setting is rural, 2-lane, and multi-lane and undivided for all types of crashes. And notice the CMF is 0.76, or what's that, a 24% crash reduction factor for putting edge lines and center line markings on rural 2-lane or multi-lane undivided roadways. And of course, these lines have, I think, value or benefit to drivers in terms of their navigating the roadway. Here we see a 2-lane, 2-way rural roadway with no markings. And I think you can see how drivers, number one, can't really see clearly, especially at night, if you think about it, the edge of the roadway, nor can they see of the specific distinctions in terms of westbound or eastbound lanes of travel. So putting in a yellow center line will help, at least in terms of separating the eastbound from the westbound direction of travel. But also, if we were to add edge lines, I think you can see how this would enhance the driver's ability to see the edge of the road. And again, remember, our thought here is to what things can we do to help keep vehicles on the roadway? And I think this center line and edge line pattern that you see here would do that. A case study from Missouri showing the effectiveness of edge lines. Notice before 2008, Missouri DOT did not stripe edge lines on roadways with less than 1,000 vehicles per day. And they looked at data from 2005 to 2007. They had 35,000 line miles with less than or equal to 1,000 ADT. And they had 339 fatalities and about 2,300 disabling injuries. They had 13,000 line miles with volumes between 400 and 1,000 vehicles per day. And in that category, they had 219 fatalities, 1,500 disabling injuries. So 2/3 of the fatalities and severe injuries happened in that 400 to 1,000 vehicle per day category. So on that basis, the DOT painted edge lines on 73 routes in 2009. There were 1,138 edge line miles. And so they had some before data. They also had some after data, and they could look at the effectiveness. This was from various counties. They looked at the total severity level, and they also looked at F and DI as fatal plus disabling injuries. And you can see that the crashes were reduced. And the effectiveness for total crashes was 15.2, and for fatal and disabling injuries was 19.3. The total crash reduction was statistically significant at the 95% confidence level. The fatal and disabling injuries reduction was not significant at the 90% confidence level. But as a result of that study, the Missouri DOT decided to paint edge lines on roadways with between 400 and 1,000 ADT. Question comes up sometime, are wider edge lines better? Here you see the standard 4-inch line on the left, and then the 6-inch wide line on the right. And just visually, I've heard older drivers talk about how they prefer the wider edge line, but what does the data show? Again, this comes from the CMF clearinghouse. The countermeasure is install wider markings without resurfacing. So that's not part of a paving project, but just install wider markings. And this is in rural areas. Fatal, serious injury, and minor injury crashes. And on the left, you can see the CMF is 0.78. The CRF, of course, would be 22%. So it appears that wider edge lines do have a crash reduction effectiveness value of about 22% based on this study. The Texas Transportation Institute at Texas A&M University also looked at width of edge lines. They found that wide edge lines reduce total crashes between 15 and 30%, and fatal and injury crashes by 15 to 38%. They also found, in terms of benefit cost ratio, the benefit cost ratio was between $33 and $55 for each dollar spent. So that would be a significant benefit cost ratio, in my opinion. They also found that wider edge lines offered similar results, but without the concerns associated with shoulder rumble strips. So the findings in terms of crash reduction or effectiveness were similar to the shoulder rumble strips. And we'll talk about rumble strips probably tomorrow. Some of the concerns are for bicyclists and for noise and those kinds of things. We're talking about pavement markings. There's a variety of different materials available. They do need to be retroreflective, often accomplished with glass beads, but they can be supplemented with raised pavement markers or recessed pavement markers, which provide a kind of a higher level of retroreflectivity. In the image there, you see a recessed pavement marker. Pavement's been milled and the reflective material has been placed below the pavement. So it's protected from wear from traffic, also protected from snowplow blades. But all pavement markings do have maintenance issues. They wear out, they can lose their retroreflectivity. They can be covered by mud or snow or ponded water, that sort of thing. But pavement markings are a way to help keep drivers on the roadway. Some agencies use enhanced pavement markings, the so-called biscuits or cookies, which you see provide a kind of a raised surface above the normal line. The issue with this, though, probably in the northern part of the United States, Ohio, West Virginia, and so forth, is, of course, these are very susceptible to snowplow damage because they protrude or project above the pavement surface. Another pavement marking that's been used, I believe, in Pennsylvania, perhaps other states, is the curve advance markings. These are pavement markings that provide information about the curve, and they're on the roadway, so they're in the driver's direct line of sight in their field of view, and they supplement the curve warning signs that would still be needed on the roadway. So these are a supplemental type of measure. And if some of you may be familiar with this, others may not be, but this is what's referred to as the curve advanced marking. Notice it's two transverse lines, a curve arrow in the direction of the curve itself, and then the word slow. And the advanced warning sign for the curve would be just off to the right outside the image. Again, these are a supplemental measure. They're not intended to replace the advanced warning signs. And so there'd be two of these for this curve, the one we see here, and then for traffic coming in the other direction in advance of the curve on the other side. And some preliminary data analysis from PennDOT shows a 33% crash reduction in roadway departure crashes. Another marking, I believe this first appeared in the 2009 edition of the MUTCD is the speed reduction markings. You'll notice these are kind of relatively short transverse markings that as the driver approaches, in this case, the curve, the markings are spaced closer together. So they give drivers the illusion that they're traveling faster than they are, and that hopefully the driver will instinctively slow down. And in my travels, I'm starting to see more and more of these used, not only in advance of curves, but some states use them in advance of, say, as a 2-lane rural roadway enters maybe a built-up area or unincorporated community or that sort of thing. They use these speed reduction markings as a way to try to get motorists to slow down going through the built-up area. These are included, as I said, in the MUTCD, and this probably shows better what I was trying to describe. Notice how the lines, the transverse lines, get closer together as the driver approaches the curve, in this case coming from the left to the right. But the MUTCD allows them only where longitudinal lines are present on both sides of the lane, meaning longitudinal lines could be a center line and an edge line, and they're no greater than 12 inches wide and should not extend more than 18 inches into the lane. Something else to consider to help keep motorists on the roadway is where you have barriers, roadside barriers, delineate the barriers. You can see here example of concrete barrier rail delineation, both the daytime and nighttime view of it, and also the delineation on metal W-beam guardrail as well, daytime and nighttime view. Another example here, notice the W-beam guardrail, and they've put reflective tape inside there, and it makes an effective form of delineation of the curve in the roadway. So signage to keep vehicles on the roadway. We've looked a little bit at pavement markings. Now what about signage? And you see some of the examples of some of the, we call them the horizontal in curves. The crash types addressed by signing are curve crashes, of course, include category, also nighttime crashes, again, mostly run off the road crashes. What about warning signs for curves? Here you see a warning sign, notice no advisory speed, but a warning sign for the curve. And you see some results from the crash modification factors clearinghouse for different conditions. The first line there in that table is the, let me try this pointer. This pointer may be better. Notice here, CMF is 0.7, 30% crash reduction factor. This is for all crash types for serious injury and minor injury crashes. And the second line here down below is for property damage only crashes, PDO crashes, all crash types, and the CMF is 0.92 or an 8% crash reduction factor. One thing I didn't talk about when I mentioned the CMFs is that the CMF clearinghouse does rate the quality of the research on which these factors, crash modification factors, are based, and you can see it's a 5-star type of rating. So that's one of the things to look at when you're thinking about using a particular CMF. And notice both of these studies rate only 1 star. So apparently there's concerns about it could be the sample size used, it could be other factors, but I'd probably think twice before I might use results from studies with just a one star. So something else to think about when you're considering using the CMFs. There's also been a lot of research done on CMFs for chevrons. And notice the scene here. To me, this is really where the value of the chevron is most significant. Notice the kind of a hill crest here. The roadway maybe dips on the other side of the hill, and it's difficult to see the actual alignment of the curve. But notice the chevrons, because of course they are above the roadway, they are visible to the motorist, even though the pavement surface may not be. And so the motorist can see from a distance ahead of the curve how sharp the curve is. And here you see a variety of different studies dealing with chevrons, and I'm not going to go over each of those, but notice the CMFs range from 0.96, which would be a 4% crash reduction factor, to 0.36, which would be a 64% crash reduction factor. And notice in the quality column there, it appears all of these studies have 4 stars. So I would probably feel pretty good in terms of using these CMF values for the specific situation. You'll notice there's a variety of different crash types and crash severity situations that are included there. What does the 11th edition of the MUTCD, which came out about 2 years ago this week, I think, what do they say about warning signs, especially related to horizontal alignment warning signs? And one of the standards in the MUTCD, section 2C.01, is that the use of warning signs shall be based on an engineering study or on engineering judgment. They identify a number of horizontal alignment signs, including the turn sign, the curve sign, reverse turn and curve, winding road, and so forth. They also talk about the advisory speed plaque. Chevron alignment signs also fall into this category. They also mention delineators and also the one direction large arrow sign. So these are all considered in the MUTCD as horizontal alignment warning signs. And here you see some of those depicted pictorially. Section 2C.06 talks about device selection, and this is one area I should note that in the MUTCD, in the 11th edition, this is one area where there is some significant change from the previous edition. So we'll go through here, and this is in the area of device selection, which has changed significantly in the 11th edition. And that actually made it sort of a multi-step process now compared to what it was in the previous edition of the manual. But they show criteria in chart A of table 2C-4, which we'll look at in a minute. But notice it says those criteria shall be used to determine the need for devices for changes in horizontal alignment. So it's kind of a two-step process now. You use chart A to determine the need, and then if the use of a device or devices is indicated by chart A, then you use chart B of that same table. Notice shall be used to specify the types of devices to be used in advance of and or along a horizontal curve, except as provided in paragraphs 3, 5, and 6 of this section. So it is a little bit more involved process than it has been in the past, but we'll go through it and then we'll look at a little example as well. but it's a multi-step process now. The speed differential in chart B, notice they say shall be the difference between the horizontal curve's advisory speed and the roadway's posted speed limit, the statutory speed limit if none is posted, or the 85th percentile speed on the approach to the curve, sometimes called the prevailing speed. So notice users can determine that speed difference based on the difference between the advisory speed and either the posted speed limit, the statutory speed limit, or the 85th percentile speed on the approach. I think that's a little more flexibility than existed in the previous edition of the manual in terms of that speed differential. And I mentioned the paragraphs 3, 5, and 6. This is what paragraph 3 says. A one direction large arrow sign may be used in place of or to supplement delineators or the chevron alignment signs when A, site conditions limit the number of delineators or chevron alignment signs that are visible, or B, the number of delineators or chevron alignment signs that can be installed within the change in horizontal alignment is less than the number determined by the spacing specified in sections 2C.08 and 3G.04. So they allow the use of the one direction large arrow in place of or to supplement delineators or chevrons when you may be limited in the number of chevrons you can use. And an example, I think I may show it later on in the week, but there's a curve I'm familiar with, not too far from me, that relatively sharp curve, really or chevrons should probably be installed. But right at the outside of the curve is an area where like 3 or 4 driveways come together into one big driveway or access point to the roadway. And of course, you couldn't really reasonably put chevrons in that area of the driveway opening. So this is saying you could use a one direction large arrow in that situation. Paragraphs 5 and 6. Paragraph 5 says devices for changes in horizontal alignment may be omitted when the speed limit on the approach to an alignment change is 20 miles per hour or less. And paragraph 6 says devices for changes in horizontal alignment may be omitted on urban streets with an AADT of 1,000 vehicles per day or less. So here they're talking about in 5, they're talking about low speed roads. Number 6, they're talking about lower volume roads in urban areas where those devices can be omitted. And notice it's a may be omitted, so it's an option. So I mentioned table 2C-4A. This is the table from the 11th edition of the METCD that relates to application of traffic control devices for changes in horizontal alignment. And part A, as you can see here, this table is titled Determination of the Need for Devices for Changes in Horizontal Alignment. So again, it's a 2-part table. Part A is the need. Part B is what devices do we need. And those of you familiar with, I think it was table 2C-5 in the previous edition, you'll note that this is kind of a different approach than was used in that earlier edition. Here on the left, they identify the roadway types. There's 4 categories of roadways. And then there's 4 columns here on the right side of the table, the AADT values from less than 1,000 vehicles per day to greater than 3999 vehicles per day. And notice there's a couple footnotes here. Footnote 1, which is associated with the title, if devices are determined to be needed, the selection of the device is based on chart B below. So it's, again, it's a multi-step process. And then footnote 2, which you see here with arterial or collector with pavement markings, says an arterial or collector is considered to have pavement markings when either a center line, edge lines, or both are present. So they explain that a little bit. And then part B is selection of devices for changes in horizontal alignment. And notice here, there's two columns. There's a speed differential column, 5, 10, 15, or 20 miles per hour or more speed differential. And then there is a column, devices for change in horizontal alignment. And the footnote here says, the provisions for the use of horizontal alignment warning signs and devices are contained in section 2C.06. The need for devices is determined by chart A above. So these, actually in the MUTCD, these are both parts A and B are together, but for ease of readability, I've split them up into two separate slides. But you'll notice they list the specific devices under each of those conditions. Section 2C.07 addresses horizontal alignment signs. It says if table 2C-4 indicates that a horizontal alignment sign is required, recommended, or allowed, the sign installed in advance of the curve shall be a curve sign unless a different sign is recommended or allowed by the provisions of this section. And the guidance says a turn sign should be used instead of a curve sign in advance of a horizontal curve that has an advisory speed of 30 miles per hour or less. And they also talk about the reverse curve or turn sign and where those are to be used. And they also talk about multiple curves, the winding road sign. And you can see the specific conditions where that would be used. And you can also add a next so many miles distance plaque below the winding road sign where you have a continuous roadway curvature existing for some distance. And then 2C.08 also addresses the chevron alignment sign. And I think they've made this a little more specific than the previous editions. Notice, if used, chevron alignment signs shall be installed on the outside of a turn or curve in line with and at approximately right angles to approaching traffic. The chevron alignment signs shall be installed at a minimum height of 4 feet, measured vertically from the bottom of the sign to the elevation of the near edge of the traveled way. So they specifically mention, now I don't believe that was in previous versions, that the chevrons shall be installed at a minimum height of 4 feet. Table 2C-5 gives the typical spacing of chevrons, and I believe this is the same as appeared in the previous edition of the MUTCD. It's based on notice advisory speed or curve radius. They also mention advisory speed plaques and what they call confirmation advisory speed plaques. And the use of those shall be, notice the requirement, shall be in accordance with table 2C-6. And they give the same advice I mentioned earlier in terms of determining the speed differential. So here's the advisory speed plaque. Note the warning sign, the turn warning sign with the advisory speed plaque underneath it. And notice they shall be used where an engineering study indicates a need to advise road users of the advisory speed for other roadway conditions. And notice here is the confirmation advisory speed plaque. This can be used. Notice both of these are optional. Can be used below in this case, the right arrow. And they have table 2C6 that specifically relates to advisory speed plaques. And notice it's based on speed differential. And for 5 miles per hour, the advisory speed plaque use is optional. 10 mile per hour differential is recommended. 15 miles per hour or more, it's required. And a couple more notes. Notice that advisory speed plaque shall only be used to supplement an advance warning sign. The advisory speed plaque or the confirmation advisory speed plaque shall not be installed as a separate sign installation. And I think this is new as well. Sometimes in my travels, especially in small towns or villages, I would see that advisory speed plaque posted as I think it was intended as a speed limit, but now the manual specifically prohibits that practice. And notice the confirmation advisory speed plaque shall only be used to supplement a one direction large arrow sign and shall not be installed as a separate sign installation. Same sort of thing. So let's look at an example. Again, appropriate, we have snow on the ground, like probably many of you do. Let's look at chevron alignment warning signs for curves. So we see here a 2-lane roadway that have a yellow center line, double yellow center line. There's no edge lines that might be covered in snow, but I can tell you there's no edge lines. But notice there is a curve warning sign here on the right. And if you look carefully in the distance, you can see some chevrons. So they have some chevrons, but if you look closely, looks to me like all the chevrons are kind of in the first half of the curve rather than being kind of equally spaced throughout the whole length of the curve. So there probably are some issues with the chevrons, but the situation is this is a collector roadway. The average daily traffic volume is 1,200 vehicles per day. Posted speed limit is 55. The advisory speed for this curve is 40. And my question is this curve signed appropriately? So now let's use these charts and tables we've just talked about in section 2C of the manual to see whether this curve is signed appropriately. So remember we start out by referring to table 2C-4A, which is determination of the need for devices for changes in horizontal alignment. So we look at roadway type here, not a freeway or expressway. We have arterial or collector without pavement markings. Well, that doesn't apply to us because we could see there's a double yellow center line on this collector. And now we have arterial or collector with pavement markings. So this would be the relevant line in this table. And the AADT, what was it? It was 1,210, I think. So it falls within this range. And so this tells us that devices are recommended for this change in horizontal alignment. So then we go to part B, which would tell us what devices should be used. So now we're selecting devices. In part B, one of the key factors is the speed differential. And let me back up here. What did we say? We said the speed limit was 55. The advisory speed is 40. So that's a 15 mile per hour differential, speed differential. And so that would be this row right here. And the devices that are recommended here are delineators and advanced horizontal alignment warning sign. And delineators would also include chevrons are considered to be a delineator. So delineators and advanced horizontal alignment warning sign. So there are chevrons around that curve or around part of the curve. So they've got part of that right. I would want to look at what would be the appropriate spacing of those chevrons. And we have an advanced horizontal alignment warning sign. So let's take a look at that. Do we need an advisory speed plaque? Actually, let me back up here. Notice table 2C-6, for a speed differential of 15 miles per hour or more, the use of an advisory speed plaque is required. So chevrons are there. They're not appropriately spaced. How would we space them? Back up to here. Advisory speed was 40 miles per hour, so 35 to 40. So the spacing of the chevrons should be 120 feet apart, according to table 2C-5. So they have chevrons, but they need to be spaced about 120 feet apart around the full length of the curve. They have a warning sign, but as we just saw, for a speed differential of 15 miles per hour, which we have here, the advisory speed plaque is required. So that would need to be added to bring this into compliance. So any questions on that?
No, thanks, Ron.
Okay, thank you, Mike. Questions come up sometimes. How can we determine the recommended curve advisory speed? There's several different ways that this might be done. One is to use an accelerometer in the vehicle that gives you a direct determination of side friction factors. We could use the design speed equation from Roadway Design. We'll talk about that, if not today, then tomorrow. Or many agencies, I think, use the traditional ball bank indicator, like you see at the bottom there, that kind of curved device, similar in that there's a spirit-filled tube there with a item in it that moves as the vehicle goes around the curve, and you can see the criteria for using the ball bank indicator. So these are all ways to determine the curve advisory speed.
Hey, Ron.
Yeah.
Hi. Quick question from our previous example. Question from Jeff. He says, can you use a tighter chevron spacing than required?
I would say yes. Yeah, how do they word that here? The sign spacing, I'm not sure, it doesn't really say it here, but I would view this as sort of the maximum. I would say yes, if you'd want to make a tighter spacing, because I think there may be cases where that would be appropriate. I would say yes. I'd probably document, why you were doing that and what spacing you were using, but I think that would be appropriate.
Thanks, Ron.
Good question. Thank you, Jeff. This is just support for that curve advisory speed. Notice it says research has shown that drivers often exceed existing posted advisory curve speeds by 7 to 10 miles per hour. I would just add, I'm not sure we need research. I think most of us as drivers have probably seen that or done that ourselves, that you can oftentimes exceed the advisory curve speeds by 7 to 10 miles per hour. There is some guidance available on advisory speeds. Federal Highway Administration has procedures for setting advisory speeds on curves, and you can see what's in the handbook that they have. Another thing to consider, again, we're still talking about using signs and markings to keep drivers on the roadway. There are ways to enhance warning signs for curves. We can oversize the sign. It's a way oversized sign, warning sign, but that's a way to make it more conspicuous, to enhance the warning. We can use an oversized background and yellow flashers like you see here. Notice that this kind of the normal warning sign for trucks, but we've put it on a large background with flashing lights to make it more conspicuous to the user. Doubled up warning signs, notice one on each side of the road. The MUTCD requires signs on the right side. If we want to double them up, that means putting one on the left side, not putting one on top of the other. That's not permitted. This is Arizona. Notice they've doubled up the warning signs, but also have yellow flashers on each warning sign. This, I believe, is Colorado. Notice the sign is overhead with flashers. It's kind of in direct line of sight of the motorist. And maybe more recently, dynamic signs. This sign says speed too fast for curve when flashing. So measuring the motorist speed, and if the speed is too high, then the flashers come on. Or speed feedback signs for curves. The one on the right, of course, shows the motorist speed. The one on the left is kind of a blackout sign that's black. Unless the motorist speed is too fast for the curve, then the warning sign and the flashers come on. And here's a dynamic curve warning system. Again, not trying to promote or endorse any particular product, but the video, I think, illustrates their system. So let me show that. I'm not sure if the audio will work, but if not, we'll talk about it briefly after the video.
Hello and welcome to TAPCO's Traffic Safety Video Series. Today we'll take a look at TAPCO's Dynamic Curve Warning Systems, or DCWS. These DCWS feature TAPCO's flashing LED blinker signs, which are solar-powered traffic signs enhanced with brilliant LEDs. The blinker signs provide advanced warning of and guidance through the curve and are ITS compatible. Statistical analyses show that approximately 3 of every 4 curve-related fatal crashes in the U.S. involve single vehicles leaving the roadway and either striking fixed objects or overturning. Another 1 in 10 result in head-on crashes. Also, the average accident rate for horizontal curves is about 3 times the average accident rate for straight segments. Thus, fatal crashes on rural curves represent an important crash category, and improving the visibility of rural curves at night has been shown to reduce this type of crash. An advanced warning system lets a driver know that the horizontal alignment of the roadway is about to change and that the driver must alter the path and possibly his or her speed to negotiate the curve safely.
So I don't know if everybody can hear that, but basically they're talking about the overrepresentation of roadway departure crashes in curves and how active or dynamic warning signs can help address that issue by providing more conspicuous guidance to motorists as they go around these curves, also warning for the curve. And many states are using these devices, and I think they are proving beneficial in reducing run off the road crashes. Mike, I think we're just about done, so this is maybe a good place to break for today, and we'll pick up again tomorrow. I want to thank everybody. Thank you for your questions, and have a good rest of the day, and we'll see you tomorrow. Mike, I'll turn it back to you if you have any final housekeeping items.
Thanks, Ron. Do we have time for a question or two?
Sure.
Okay. We have a question from Kessa. She's asking, are these enhancements allowed based on an engineering study or judgment, or with an experimentation permission, or what is the process?
It's my understanding these are allowed based on engineering study, that it would be okay to use them. I don't believe it's required to get, the experimentation process.
Thanks, Ron. There's a comment from Michael. He says, quote, with regard to that oversized warning sign at the PC with the 50-mile-an-hour advisory speed, those types of warning signs were removed from the 11th edition of MUTCD, end quote.
Yeah, good point. Yeah, thank you. That's a good point. Yeah, the sign, the type of sign, the message on the sign is no longer in the MUTCD, but it is still okay to use the oversized format to warn drivers. But yeah, thanks for catching that. That's a good point.
All right, thanks, Ron. Those are the questions for today. We really want to thank all of our participants for joining us today. Day 2 of this series will be tomorrow morning at 10 a.m. Eastern Time. And please note that we did have each person register individually for all 3 days. So you will have a new link to join for tomorrow's session. So please check the email confirmation for day 2. Thanks again so much, and we'll see you then.
Thanks, everyone. See you tomorrow.